This is a small presentation regarding one of the doubt clarification, because I wanted this doubt to be clarified to all the students. So I am discussing this with everybody. So this was sent by one amongst you in the query. So this was in the previous assignment. This question is like this, that there is a charged particle somewhere on this line having some mass, and it is resting in equilibrium at height h above the center of uniformly charged non-conducting horizontal ring whose radius is capital R. So what is given? There is a ring placed horizontally like this. It has some charge q, and on its axis at some distance, and that distance they have given as h. At some distance h on the axis, there is a point charge, some value, say small q, and it is at equilibrium. Equilibrium means net force is 0. Question is that this equilibrium will be stable for which values of h, and there are 4 options given here. There is something specialty regarding this r by root 2. Before I discuss this particular question, let me remind you students, in the beginning of these enrichment classes, I have discussed one question like so, that if there be a ring of radius r having charge q uniformly distributed on its circumference, then on its axis if there be a point at distance x, then the electric field at this point was given by the formula 1 by 4 pi epsilon naught q times x upon r square plus x square to the power 3 upon 2. If you have forgotten this particular formula, I will suggest you to first do that particular question, and after that I have asked you to find the maximum location of maximum value of E. For what value of x is this E maximum? For E to be maximum, we have solved this question, if you remember, dE by dx is equal to 0, and this gives you the value of x as r upon root 2. Plus minus r by root 2, it can be positive or it can be negative. That means for x is equal to r by root 2, the value of electric field is maximum. And the graph, if you remember, we have also discussed the graph. This is electric field along y-axis, and this is x. X is the distance from center along the axis. At the center of the ring, you know electric field is 0, and at x is equal to r by root 2, electric field is maximum. So the graph was something like this. After r by root 2, it will decrease, and before r by root 2 also it decreases. So why I recall this particular question? For the time being, you should remember that for a ring, the electric field is having maximum value at a distance r by root 2 on its axis from the center. At the center it is 0, and at infinity also it is 0. Here also the radius is r. Suppose this distance, suppose there be some point, let this point be somewhere here. This distance is r upon root 2. That means if you put the charge q over here, at this point the force on this charge will be maximum, because electric field at this location is also maximum. Now we have to see what will happen here, what will happen here. 2 points we should consider. Let's see one by one. At this point I told electric field is maximum, which I am writing as E max. The electric field will be maximum. If I go above this point, then electric field will decrease in upward direction above this point, and if I go below this point, again electric field will decrease only and will become 0 at this point, and will also become 0 at infinity. Here the electric field is maximum. First I consider this point. This is a point on the axis for which the distance is less than r by root 2. This is h. At this point we are placing the charge q. On this charge there will be two forces. Electric field, we assume it to be positive, will be in upward direction, and gravity will be in downward direction. Gravity we write as mg, and electric force will be how much? Q times E. We are considering this point. Now at this point, suppose it is at equilibrium. It is given, it is at equilibrium. We have to find whether it is stable equilibrium or not. What is the meaning of stable equilibrium? Stable equilibrium in case of mechanical problems, I have discussed earlier that if there is a ball on a pitfall, this is stable equilibrium, because if you displace it slightly, it will come back to its original position. But this is unstable equilibrium. Here it is at rest, at equilibrium. But if you displace it slightly, it will not come back to its initial shape, initial position. We have to test whether this equilibrium is stable or not. At this point there is equilibrium, means I can write QE is equal to mg. This point I will call it as A. This is electric field at point A. These distances are very small, so if you go slightly upward or downward, we will assume that mg is not going to change. Mg should be treated as constant. Now suppose I move slightly below this point, below A. I come to this point. Will gravity change? No, gravity will remain mg. But what will happen to the electric field? Will it remain same? No. I have discussed, on going down, the electric field is decreasing. So this factor will decrease. If this factor will decrease, the equality will no longer hold. So the left hand side, it will become, suppose this point is C, so this will become QEC, and as I have discussed, EC will be less, so QEC will become less than mg. That means mg will become more. If mg will become more, the downward force will become more, upward force will be less. So what will happen to the net force? Net force will be in downward direction. Do you think if you slightly shift it from point A to C, can it come back to A? No. Why no? Because on shifting to point C, the net force comes out to be in which direction? Net force will be in downward direction. That's why this is unstable equilibrium. Let's see one more case. If it goes upward, here we have seen QEA is equal to mg. Now if we shift slightly upward, what will happen to QEA? QEA will increase, because in downward direction electric field is decreasing. If we move slightly upward to this point, we are going towards Emax, so electric field is increasing. So this factor will become more. Suppose this point is D, then I will write Q times ED will be slightly greater than mg. Mg is in downward direction, this is in upward direction, so the upward force will become more. If you slightly move it upward, the upward force will become more, and therefore it will not be able to come back to A. So what we discussed? We discussed that below this point of Emax, if you go down, downward force increases, and if you go up, upward force increases. In both the cases, the object cannot come back to A. That's why we cannot have equilibrium for those points which are below this point. Which point is this? This is the distance, this is the point at a distance of r by root 2. So less than r by root 2. If we have h less than r by root 2, we cannot have equilibrium. Let's see what happens for distance greater than r by root 2. So this is r by root 2 distance. Let's see what will happen for points above this one. Now this distance is r by root 2. We choose some point. Now suppose this point is A, and it is at equilibrium. So the gravity mg in downward direction and QEA in upward direction, they are equal. So we shall write QEA is equal to mg. Suppose we slightly move downward to some point, say B, towards this maximum electric field value. If we move from A to B, what will happen to the electric field? You see, electric field was decreasing upward. So in downward direction, electric field will increase. So this value will increase. So the left hand side will become more, right hand side will become less. The left hand side will become more means upward force will become more, gravity will remain same. So gravity will remain same. So what will happen to the net force? Earlier it was 0, but now the net force will be in upward direction. If net force is in upward direction, this charged particle Q, if you try to bring it to B, net force becomes in upward direction, so it will come back to the point A. Is this clear, students? That's why this equilibrium can be a stable equilibrium. Let's see what happens if you take this point instead of downward, upward. Suppose I move it upward. Here QEA is equal to mg. Now you can understand yourself, students. At this point both these forces are equal. If you shift upward, gravity remains same, but what happens to the electric field? On shifting upward, electric field decreases. So this will decrease, but gravity will remain same. So this will become less. That means gravity will become dominant. It will become more. And in which direction gravity is acting? It is acting in downward direction. So the net force now will act in which direction? Downward direction. So if you shift it to a point B above A, the net force will act in downward direction, and that's why it will shift back to the initial position A. Since shifting the charge above and below this point always makes the force direction in such a way such that it brings it back to its initial position, that's why these positions corresponds to stable equilibrium. And which points are these? These points are above this line. Which line is this? This is the point which is at a distance r by root 2 from the center. Above r by root 2. If our h is greater than r by root 2, only then we can have stable equilibrium. Since c is wrong, a will also be wrong. It can't be for all values of h, and only h by is equal to r by root 2. Likewise, you can, if you go down below that point, it will not come back to its initial position, as I have explained you earlier. So I hope this doubt is clarified. Please practice this again. And as I told, before solving this question, what I have discussed here earlier during earlier classes, please revise it, then you will be able to solve this particular question. I thank you. See you in the next video.